Hi, I'm Randy Barnett for Fluke. With 35 years of experience as an electrician, I've become a power quality expert and electrical trainer. In this video, we're going to talk about transformer problems. Now, we're all familiar with 60-cycle hum in a transformer, the vibration of those steel laminations in the core at 60 cycles per second. But if that transformer starts to buzz and overheat, you've got problems. The good news is finding the culprit may not be that difficult. Unfortunately, some of these problems occur intermittently. So what you're going to have to do is log some data over time and then go back and analyze in order to find your transformer problem.
The top 5 things that commonly cause transformers to vibrate or buzz or hum excessively loud are loose connections, excessive harmonics, unbalance, overloading, and cooling issues. Before I start, I always check the nameplate for the transformer ratings. Be sure to record kVA and the voltage and current ratings for both the primary and secondary sides. Record the ambient temperature and temperature rise information, and note any required installation clearance requirements, usually found on a separate label. All of this data will be used later. If you suspect your transformer is overheating, your next step can be to use your hand to feel the area around the transformer for any signs of excessive heat. It's important to use the proper personal protective equipment, or PPE, when inspecting and testing a transformer. Set up your boundaries and select the appropriate PPE for that category. Listen for any abnormally loud humming or buzzing noises. Be alert for the smell of overheating insulation. You should scan the transformer with either a thermal imager or an infrared thermometer. That requires taking off the cover. Determine the hazard risk category for the job, either from the arc flash label or, if not present, from the tables in NFPA 70E. Compare the temperatures of similar components, such as terminations and coils, to one another. A higher temperature on one phase may indicate unbalance. A higher temperature on the neutral termination may indicate the presence of harmonics. If the temperatures you read throughout the transformer are substantially higher than expected, and the unit isn't in direct sun, then you've got a problem with overloading and cooling. Another thing to look for in a thermal scan is loose connections. Long-term vibration can loosen connections, and this can cause both overheating and sometimes excessive buzzing. Before connecting your Fluke 435 Power Quality Analyzer, make sure you have selected the correct distribution system. When connecting the Power Quality Analyzer, be sure to follow the color coding scheme on the View Configuration screen. For example, in a typical 208Y 120 volt system, we use black for phase A, red for phase B, blue for phase C, and white for the neutral. When connecting the current clamps, make sure the arrow on the clamp points towards the load. When connecting the voltage leads, make sure to always connect the ground lead first for safety. Then, connect the remainder of the voltage leads. Following the correct color coding scheme greatly reduces the chances of connection errors. Use the phasor screen to quickly check for unbalance. Since the length of the phasor represents voltage level, a shorter voltage phasor may indicate an unbalance problem. Compare the amps on each phase using the volts, amps, hertz screen. The maximum voltage unbalance is generally 2%. That is, the voltage on any one phase should not vary by more than 2% of the average of the 3 phases.
So, if you suspect an unbalance issue, go downstream to the next load and check phasors until you find the source of the problem.
The most common cause of unbalance is a change in load configuration. It may help to quickly map out your overall equipment distribution system and develop or update your load schedule and drawings. Total the loads per phase and verify each phase carries a fairly equal load. Back to our transformer. If the voltage and current are reasonably balanced, then check the harmonics screen. Is total harmonic distortion, or THD for voltage, at less than 5%? If it is higher, dig into the individual spectrums, the 3rd, 5th, and 7th harmonic, and determine the source of the harmonics. Excessive harmonics on the third or fifth level often point to interference from electronic loads. If you do find evidence of harmonics, move downstream from the transformer to the individual loads. Look for things like high-efficiency lighting systems. When you find the root cause, you'll probably need to install a filter. Let's talk about a transformer that's running hot. Start by checking for overload. Check the power readings on the Fluke 435 power quality analyzer. Compare kVA, voltage, and current against the notes you took from the nameplate earlier. If the actual power consumption you see is less than the nameplate, check for unbalance or harmonics. If you don't find an unbalance or harmonics issue, the transformer's cooling system may not be functioning properly. If the power consumption you see is greater than the nameplate, you have an overload issue. Evaluate the consumption at the loads downstream and evaluate the overall load schedule and capacity. You may need an additional transformer.
So use a combination of whatever test tools you need to in order to find and correct those transformer problems. If you don't, you're going to lose that transformer. For Fluke, I'm Randy Barnett.